We are talking about parallel lines and proportional parts, and we want to use proportional parts within triangles. So here we want, in example 6, we want to find the length of DE. So DE is right here. In this example, we are talking about the midsegment theorem. And the reason that we know that this is a midsegment is because D is the middle of BC. So that's the midpoint because there's one congruent mark there and one congruent mark here. And E is the midpoint of BA because we have 2 marks there and 2 marks there. So we know that that's the midsegment. So the midsegment tells us that this line is parallel with this line. And it also says that DE is half of CA. So we can set that up right now. DE is equal to, and the things that never change, we always have that 1/2, and 1/2 always goes with the bigger side or the bigger segment. So DE is here, CA is there. We can clearly see that CA is larger. And then we can substitute the value in that we know, and the only one we know is 8. So DE is equal to 1/2 of 8. And so we get DE is equal to 4. Looking at example 7, again, this is the midsegment. We have 2 congruent marks. That means K is the middle of DC. And then we have 1 congruent mark. So we know J is the middle of BC. We know the full length of DC is 12. And we know that the length of JK is 9. And it says find BD. So we want to find BD right here. So we're giving 9, and we want to find BD. We're still going to use the midsegment theorem because if this is the midsegment, there's a relationship between these two. And the relationship is these 2 lines are parallel. And JK is half of BD. So we can say JK is equal to 1/2 of BD. Well, we know what JK is, so we can substitute in 9, and that is equal to 1/2 of BD. And we want to solve for BD. So what we can do is we can multiply both sides by 2. The reason that is this 2 cancels this 2, and we're left with just BD on the left side. And 2 times 9 is 18. The length of BD is equal to 18. We have another example, number 8. And again, this is the midsegment because we have 1 congruent mark and 1 congruent mark. So I is in the middle of GF. And then we have 2 congruent marks on each side of J. So J is the middle of GH. And because it's in the midsegment, that means that these 2 lines are parallel. And it also means that IJ is equal to 1/2 of FH. So we can substitute our values in, and on the left-hand side, we have 2x minus 11. And that is going to be equal to 1/2 of fh, which is x plus 2. Now, we could distribute the 1/2 in and get 1/2 x and 1, and then continue to solve from there. But I don't like really working with fractions, so I want to just get rid of this 2 altogether. And one way that we can do that is we can multiply both sides by 2. So we multiply by 2 here, and the 2's cancel. And we multiply by 2 here on this side, and that means we have to distribute the 2 to both terms on the left-hand side. So 2 times 2x is 4x, and 2 times negative 11 is negative 22, and that is equal to x plus 2. So I can subtract x and subtract x. On the right-hand side, we just have 2 because our x's cancel. On the left-hand side, we have 3x minus 22 is equal to 2. Next, we can add 22 to both sides, so that will cancel. And then we get 3x is equal to 24. And then last, we can divide both sides by 3, and we get x is equal to 6. And that is what we are asked to find.